I'm gonna move y'all over here. Oh, that sounded weird.
I'm gonna have to hold it up.
I will. I'm gonna read it and then I'm gonna hold it up. Okay. So my 30-second speech. My POC is, what signs could neurons be sensitive to that make us tired and/or awake? This is from pathophysiology. We're taught like this week we've been talking about like sleep deprived and like not getting enough sleep and how much hours you need to rest in order to have enough energy to have a normal day. So in my notes so far, I put the VLPO. I don't even know what it means because it's not in our notes yet. I'm gonna have to ask her tomorrow. I don't know what it means, but I know that it is the areas in the hypothalamus that puts us to sleep. So I know that that's what makes us tired. And then the arousal neurons are areas in the brainstem that keep us awake. But there's sensitive like signs that go on that are in our notes that are going to tell us the answer to my POC, which I'll get into that in a second. But I'm going to let Kenya write this and whoever actually watches this later. Oh goodness, I'm shaking. I'm sorry. I feel like I'm shaking so bad. Let me know when you're good, Kenya. I'm good. Okay. We're gonna go right there. Do y'all have any questions that could help me with my POC or anything like that for the ones that have the class? Yeah, I don't remember how to say it, but I know what they are. They're all in our bodies. I'm gonna go through my notes. Okay. So like the vilpo, I know that it's in the back of the brain, and then the arousal neurons are like in the middle of the brain. So like, hang on, I'll draw a brain.
So there's something specifically in your brain that makes us go to sleep?
Yeah. It's like what controls it and stuff like that.
So that has to be called something.
Mm-hmm.
Do you know what that something is?
Nope. Because it's a whole lot of stuff. Does that look like a brain?
Yep.
No. It's whatever. So like right here, that's where that is, and then this whole thing right here is what that is. And yeah, if you want to draw the brain, all I did was draw a brain, and then I did the back part and the front part, and then pointed to the things. It doesn't have to look exactly like mine. I just threw it together with the two dots and point.
What's your question again? I forgot.
My question is, what are the signs, like what signs could neurons be sensitive to? It's in our notes.
Okay.
I remember reading over it. I just don't remember what it is, and I don't get it completely. Look, I'm going to find it right now.
You say signs, like, what are you talking about?
So this slideshow, it's titled, "But How is the Transition from Sleep to Wake Controlled?" And it's by like parts of our brains and like what we do throughout the day. So like what makes us feel tired or sleepy, it says it's dark, you ate and your stomach's full, you're just relaxed. And like feeling awake and alert is whenever there's light and you've slept good enough and you feel like if you're not stressed.
So now you're looking for signs that are those types of signs that might be sensitive to neurons.
Yeah, so like those are the signs, but it doesn't make sense to me. So it says neurons are sensitive to these signals, particularly light and dark, switch the wake and go to sleep areas on and off. But that doesn't make sense to me because if you don't get enough sleep and it's light outside, you could still be tired.
Yeah, I sleep with my.
But it's-
It doesn't
it's-
put you to sleep. You can still be tired, but it doesn't put you to sleep.
But that's what it's talking about. It's talking about whenever you're tired and whenever you're like awake.
Yeah, but you're not gonna sleep with the light on.
You just confused me.
Like, it could be light outside and you can still sleep in the dark.
So what did you say about the light again?
It says that like the light and the dark is what switch up to the wake up and go to sleep signal.
Oh, okay.
Um,
So I guess
And then-
what Adriana is saying is, even though it still may be the light outside,
mhm.
where you are could be dark, and that would indicate, that could be a sign that it's time for you to go to sleep.
Gotcha. So
Even though like outside, it's not, I mean, I don't know, I'm just throwing out some thoughts.
I don't know how to say this word. OREXIN.
OREXIN,
EXIN.
right up on the board.
Orexin.
O-R.
It's a receptor.
Mhm. It says that orexin neurons in our hypothalamus. Is that how you say it? Hypothalamus.
Hypothalamus.
Hypothalamus. I don't know. Are activated by signals that keep us something that keep their
You said it right, hypothalamus.
their receptors like in that like area that are activated by signals that keep us awake. That's in our notes. And they can also, so like when this neuron is working, it can activate this one. So I'm gonna say that this is
You need another marker?
I don't know. I feel fine, I don't care.
You said that receptor, what's that one? The brain
Hang
stem?
on. Signals to stay awake. Okay. So I put that neuron down and I said that it was a receptor and it signals us to stay awake, and while working it activates, and I didn't feel like writing it again, so I pointed. I don't know if you can see from here. Can you see what it says, or do you need me to read it?
I can see it.
Okay.
Okay, you're good.
Okay. I'm gonna look through these names again. So that's what it is. So this is what keeps us awake, and whenever it's turned off, that's when we go to sleep. That's what it says. It says arousal neurons are switched off too, and then we fall asleep. So like when this is working, it activates this. So whenever one of them stops working, both of them stop working because they need each other to work. Okay, that's fine.
You said what you need each other to work?
These two neurons use each other. So like, because this one, if it's working, it activates that one. But if it's not working, then that one's not going to work either. So we need these two neurons in order to be awake.
Okay. You know, some people with like narcolepsy,
Yeah.
They're not really like, they like lack them.
Who's on there? Oh, it's Kenya. She doesn't have everything on mute. Hang on. I'm listening.
I don't have food.
Okay. Okay. So I put this, and I said that the orexin neurons, whenever they're off, that the arousal neurons are off too, and that means that it's sleeping. Did you get that part? Can you?
Yeah.
Okay. And then my aha moment. You don't have to write incomplete sentences because it's not a big deal. You could put like OA and AN, ON and AN. That they use each other to stay awake.
Okay, you're good.
Okay, and then I'm going to do my steps. Okay, my one is in. Oh. And then use notes. That's when I found correction. And then you can save it. Let me know when you're good, Kenya. Sometimes I'm scared that they're gonna like put themselves on mute and turn off the camera and they're gonna walk away. And then I'm just gonna hold my thing. Okay. Okay. Okay, now I'm gonna do my 15-second speech. So again, my POC is what signs can neurons be sensitive to that make us tired and or awake. So at first, I identified the first part of my notes that I did, which was the VLPO and the arousal neurons, and that was basically what puts us to sleep and keeps us awake. And then next, I wanted to know where these were at in our brain, since our brain is what makes us fall asleep and stay awake. So I used my little dots and labeled them. And the next thing I did is I used my notes from pathophysiology today off of my laptop and learned that orexin neurons is a receptor and that they keep us to stay awake. And then my aha moment, which is also my fourth step, is that I learned that neurons work together to stay awake. So if this one's not working, then this one won't work either, and that's what makes us fall asleep.